Hello everybody, my name is Rafael and I'm here to deliver the talk. It's not fast enough. So what can make a Node.js application smooth? Talk will cover interesting stuff to improve your app and save your company money. Okay? So please just introduce myself. I'm Rafael Gonzaga. I'm performance engineer at Nearform and from Brazil, and also member of a few organizations in the open source and FastFi core member, Node.js core member, and also Clinic.js core member. Okay? Please follow me on Twitter or GitHub. Normally share interesting stuff there. Okay? Let's move forward. So some of you may wonder why performance is important, why someone would create a talk just to talk about it. Before understanding why performance matters, let's take a look at common assumptions from beginners. So let's assume that you have an API that is responding in more than 1 minute. So when it goes above of 1 minute, the senior architect with 2 years of experience will say, oh, okay, that's low. I should improve it a bit. Not a bit, you know. And when it goes from 10 seconds to 20, they will say, okay, that's low, but this is an internal application that they can wait for sure. This is also bad, right? And when it goes from 1 second to 5, okay, that's fine. Let's add this task to the to-do column and do it later. And you know that the later never happens. And when it reaches 300 milliseconds, they will say, okay, it's super fast already. Any improvement will be imperceptible by end user. This is also wrong. The average of the human reaction time is 200 milliseconds. So once 300 milliseconds delay threshold is exceeded, the interaction often reported as sluggish. So this data were taken from the human benchmark study, which is very good, by the way. You need to check. And okay, so let's talk about some common issues I have seen during my journey as performance consultant and as an employee solving performance issues. Okay, the first one, network. So most people tend to believe that the reason of the delay is often in the client bandwidth. In fact, it helps for sure, but it's not a determinant factor of improvement. Okay, so once the client reaches 5 megabytes approximately, they may not see too much improvement in the page load time. And on the other hand, reducing latency will always improve the loading time. Okay, this happens because the majority of the latency caused by three-way handshake in HTTP 1.1. Okay, so in this, the first image shows the bad ISP, Internet Service Provider, that does not provide the best path to reach to the server. So for instance, you are playing a game and the end game is in another continent, you know, like you are playing, let's say, Counter-Strike, amazing game, by the way, and you are in Brazil and the end server is in United States. And your ISP is taking too much hopes to reach the server. As you can see in the image, it's going to another continent until reach to the server, and this is low. But this is not fault of you as engineer. It's fault of the ISP and their engineers. Okay, so you have nothing to do in this side. But the other one is the bad server region. For instance, the second image, you can see my blog in another continent, and I'm from Brazil. And I having 1 second of delay just to reach the server, and this is not good. Not good. Okay, don't do that, please. You need to have seen a lot of architects ignoring it. But when the service is far away from the client, it needs more hops to reach to the server, and consequently latency. Okay, so assure you understand where most of your clients are accessing our site, okay, or website. So in the case of international website, it should be configured in the proxy. So pay attention on that. Always put your server close to your client. Next one, overengineering. So let's imagine the following situation. You have the application 1 and you have the application 2. Both applications is consuming one database. You did a few measurements and you see that you saw that the P99 is 900 milliseconds. It means that 1% of your users are experiencing a sluggish, okay? And you are spending $20 more, okay? But someone joins the project with the following concept. Oh, okay, this is not scalable. What if DB goes down? Our application will crash and we are stuck. We need something way better. And then he creates a needed BFF, complex architecture, a needed BFF that with distributed database, through a message broker, calling a Lambda, and in the end of the day, you are spending way more money and your P99 is, okay? Don't do that. Everyone did it in the past, but it's not cool. It's not good. Only do architecture decisions when it's needed. Okay. Also, if DB1 goes down, you are still in trouble. Next one, bad platform use. Normally, in Node.js, as you may know, you need to know actually, it's non-blocking. And it means that you block the main loop, the main application, it will block your entire application. For instance, in this 4, the CPU will be idle till the IO operations. For instance, you are iterating over a long list of array, and you are awaiting side of the 4, you are awaiting a long IO operation. It is bad because if you generate it with Clink Doctor, we will see in the next slide how to do it. You will see that the CPU usage with a few spikes, meaning an idle time. And this is not good, okay? Because when you are performing a lot of operations, you are expecting to see the CPU on high usage, but this is not the case. When the CPU is idle, it means that your application is wasting useful time. Okay? Okay, now what? How do we start optimization? First, establish a baseline. You need to get all the current metrics. For any work, you must establish a baseline. You should get all the current metrics, the benchmarks for further comparison. Okay? Let's talk about a very important part when you are optimizing our application, that is isolating the bottleneck. Okay, so let's take a look at this analogy. You are a soccer coach, and you have the player A who kicked all the balls to the same wrong location, and you have the player B who kicks randomly, but eventually makes the goal. Which one would you choose for your team? The answer is the player A, obviously, because you just need to teach A to kick to the left. Reducing variability is essential, okay? For instance, you are performing a benchmark in your application, and you are in a Zoom call with your teammates. This is not good because the Zoom will affect your benchmark. So you need to make sure to use a dedicated machine to run your benchmark. Otherwise, you will see, false results. Okay? So, for instance, when I perform my benchmarks, I normally have a dedicated machine, a cloud provider to run out my benchmarks. So that's the way that I isolate all the bottleneck. Okay? If you are moving your mouse during a benchmark, it will affect our benchmark. This is a tricky one as well. So it really depends on what you are measuring, but it will affect. Okay? So let's talk about a few tools that we are going to use. The first one is AutoCannon. Is a load balancer. No, not a load balancer. Sorry. It will perform a lot of requests to your application. It's pretty similar to Apache Benchmark or WRK. There is a lot of few other tools that you can use. In this presentation, I will use the AutoCannon. Okay, so just bump a lot of requests to your REST API, their HTTP. Okay. Next one, Clink.js. It's amazing tool, amazing suite of that you can. It will provide a lot of insights for your application. For instance, event loop utilization, how much CPU this application is using, memory, potential problems, and okay. So I speak too much. Let's go to the code. Just shut up. Okay. Take a look at this simple Express application. We have server.post, a handler that whenever I receive a post request, I will update all the clients. And the update of the client score is basically iterating over all the current clients and then updating the client score. So just take a look at that, and just for reference, the current clients is 4 clients, just an example of 4 clients. So if you run this application with Clink Doctor plus AutoCannon, this example is an example we are using AutoCannon. We are performing during 20 seconds with 100 concurrent clients requests, and it is handling 10K, 10,000 requests in 20 seconds. Okay? This is not good, by the way. This is not good. Far away from good. Okay? So if you run this application with Clink Doctor plus AutoCannon, as you can see in the snippet, you will see that the CPU usage with some spikes, but frequently I don't. So, as I said previously, when you are performing a load test using any tool, for instance AutoCannon, we are expecting to see the CPU under high usage. And looking to this graph, we can see that this is not the case. It becomes idle time to time, right here or here, so on. Okay? What's the reason for that? This is due to platform usage. Code is iterating and awaiting for a promised resolution before firing the next one. We can be way more smart in this. Promise.all is a pretty simple solution. So this is pretty simple and very known by JavaScript developers. Now the code is firing all the promises at the same time, and consequently it will be fast. To change the code with this snippet and run AutoCannon again will handle, at least in my machine, it will depend on your machine. I was handling 200% more requests. Okay? But be careful with Promise.all. When you don't have a fixed limit or the limit is too high, this is crucial for your application. Okay? So, for instance, changing our current clients from 4 to 1,000 and performing the benchmark again, we will see that we are handling way less requests. So don't use Promise.all when the promise length is unlimited or the promise length is large. Okay, it really depends on the work. Okay, it's dangerous for your application and also a potential denial of service. But why? Okay, if you run the application with Clink Doctor, you'll see that the CPU is fine, it's doing work as expected, but the memory is not. When you run Promise.all with no boundaries, it will allocate all the promises in the heap at the same time, which leads to a potential block of the event loop to run the garbage collector. So an important note here is that the garbage collection is a synchronous task, and it blocks the event loop when it runs. When it blocks the event loop delay increases, and when the event loop delay increase, you are in trouble. Okay? So as you can see in the image here, the event loop delay is above of 200 milliseconds. It means that before any task, the event loop is waiting 200 milliseconds to any kind of approach. Okay? This is very bad. So a simple solution here is to use fill limit. There are several other libraries for promise limitation. It's completely up to you to find the best fit, but in this example, I'm using the fill limit with 300 of the limit, and then I can use Promise.all without any problem. Okay? One more important rule. Don't block the event loop. The sentence is widely shared, but I needed to add to my presentation just to make sure that we are aligned. Okay, I will not spend too much time here. I will assume that you know about it. You need to know about it. Okay, if you don't know and you are watching this video after the conference, please stop it right now and go and find and understand about the event loop and why you should not block the event. Okay, so that said, let's talk about function. Okay, profiling. So imagine a large code base. It might have several functions doing CPU work. How do we see that what function is spending more time in the CPU? Okay, so sometimes you don't know exactly which function is spending more time in the CPU. In that case, profiling is an excellent approach. Okay, and then we have the clinic flame, one of the tools from Clinic.js. Okay, so Clinic Flame generates flame graphs based on your application. And in flame graphs, the x-axis represents the combined percentage of the time that a function spends in the system, and the y-axis represents the call stack. This visualization makes the AView function easier to find, and this is pretty good, and we will look better at it. So the y-axis is basically the call stack. In this example, as you can see, handle, call, dispatch, that call, next, that call, handle. This is how the function. And the x-axis basically is the time active in the CPU. So just to summarize, wider blocks mean more time spent. Okay? So let's assume another application to check the clinic. Let's look at a feasible example. The following code does two operations, sum values and specify a big object. So here we are creating a big object, and we have the sum values, which is iterating a lot of times just to simulate a CPU work. Okay, and we have a handler, and whenever I receive a request, I will call the sum values and I will stringify a big object. Okay, so running it using Clinic Flame plus AutoClan, you produce the following flame graph. Here, as you can see, the above image sum values right here is one of the functions spending more time in the CPU. Then you have the e-tag generator, which is the full plugin from Express, and also note the anonymous space. The anonymous space is basically our code. Okay, linkflamedemo.js, and also you not see that this part is missing. What's the blank part? No, what is that? You'll see the next slides, but just as a spoiler, what is inlining? We'll see the next slide. Okay, hold on, please. So here we'll see that sum values is okay. Kernel tracing. So Clinic Flame provides a way to profile your application using kernel tracing. So through Linux Pro. Okay, basically it gets all the source C++ code symbols from V8 at kernel level. Very good. Okay, so running your application with --kernel following the benchmarks, you'll be able to see quite interesting stack trace. But just one thing, this is only available in Linux. So Mac OS and Windows users, sorry about that. Okay, try in another machine. Try Linux. You might want that. Okay, this is very good. And okay, running it with kernel tracing and enabling V8, we'll see that the blank part is a V8 internal function that is the JSON string fire. Okay, so we found what is the missing part. Okay, so it's very important to mention that JSON string file and JSON parse are synchronous. It means that if you are dealing with large objects, it will hurt your application. For instance, the last example, we were buying a big object. It means that this process of buying an object blocks the event flow. And as I said previously, don't block the event. Okay? Very good. Very good about that. Okay, let's talk about a few V8 tricks. And okay, what is inlining? I said about inlining, but this is a powerful compiler approach that affects directly the profiling analysis. So when a code a function is inlined, it's compiled into another function. Normally, it's in this image that we have the create user function and we have the generate ID. Create users calls generate ID function. And the V8, after running it several times in a hot path, V8 understands it as a hot path and a potential inlining function. And V8 will understand it and will inline this function. So it means that the V8 will compile the generate ID into the create user function. And the final binary code for this function is something like that. Okay? So it means that we will lose the stack trace for generate ID because it will be like copy and paste by the create user. Okay? So, however, since you don't have the function anymore, you might lose some stack trace in the profiler, as you have seen JSON string file example. Without the kernel trace, we were not able to see the JSON string because it gets in line. Okay? So fortunately, Clean Flames there is some trick to track it down. Okay? Okay, what expect from making a single function inlining yields 5 to 10% of improvement. Okay? It has a limit to how many functions it can inline because the risks of the optimizations. You'll see the optimization in the okay. But for instance, to run your application with -no-turbo-inlining, you see that we will handle way less requests. Your performance will vary. Okay. In this comparison, we will see that the performance decreased by 100,000 requests. It's a lot. Okay. So make sure to make your function suitable inline. Okay. Next one, hidden classes. This is a very important part of any JavaScript. In our case, the V8. So, accessing object property is the most used operation any JavaScript code. Okay, so I have my object and I use my object.key. How I access the object property, and making it very fast is critical for JS engineering. So, in order to efficiently store and access the object properties, all the JavaScript engines introduced the concept of shapes or hidden class. We use shapes as a terminology right here. Okay, so the shapes. A shape is a dictionary of an object with the exception of the value. The values can be stored and accessed sequentially in the memory, which results better performance. So, instead of values, the shapes contain the memory offset at which the value is found. So, when two objects is created with the same properties, the engine will assign the same shape. So, this is very important because it improves the memory management significantly. So let's look at this example. I love image, so you might like it. I have const A, I have the object A and the object B. Both have the same property with different values. They will use the same shape because of the property. I have the object A right here and object B. They will have the same shape to X and Y. Okay? Good. Okay? But the property order is relevant. Okay? So this example, we have the object A and object B with the same properties, but the values, the order is different. They will not have the same shape. And this is bad because it will create a new shape and then the memory management will be not good. Okay? It will not be good. I mean, if you run it with a micro benchmark, you will not see much improvement, but in large application, okay? So also, adding properties to the object change its shapes. And so if the object is modified too often, chain visit can be expensive. And adding properties to an object add a transition chain to the object. So look to the next diagram. So okay, this one we have the object A and the object B. The object A and the object B very similar. The difference is that the object B add the Z property after the. Okay, so it means that the object B contains shapes, and this code is allocating memory for 3. This is not good. Okay, they will not have the same shape as you can see here. And as I added the Z after the creation of the object, it will pose a transition chain to the other shape. So I have 3 shapes, 2 objects. This is not good. Okay. Okay, next one. Don't use the delete keyword. Please don't do it. The benchmark was retrieved from a repository that I maintain to benchmark some tricks in GitHub, so you can check it out in my GitHub file. So if you are using the delete property for some reason, I strongly recommend you just assign indefinite. You can save a lot of headache. Okay, as you can see here, when a property is deleted from an object, the engine will not use the shapes, not use the hiding classes anymore, and the property access which is lower. As you can see in this image, very slow. So instead, you can just do equals indefinite instead of delete the property key. Okay. Next tip or rule, assume it as a very important. Okay. So don't use Express is not directly maintained since 2020. There are not new features, no new improvements coming, and you must not follow the herd. Okay? Specify instead, just landed the V4, and this is very good, and also very fast. As you can see in this image, Specify handle a lot more requests than any other framework. Okay? It is community friendly. You just check in the GitHub. The documentation is very good, very good. Check it out. It's very smooth to make the change from Express to Specify. Okay. Next one. Don't use private properties. I mean, you are using Node.js 18. Very good, okay? You can use private. That's fine. But Git has resolved this issue in the latest Git version. So Node.js 18 contains this patch. But if you are using the LTS 60 version, don't use private. It's very slow. Whether you can use the underscore convention, but if you are building a library, you can use this. Okay, way more fast. You know, also solve to head access. Okay, next one. How we avoid the regressions in I wrote a CLI that auto can output, compare the throughput. Very useful to avoid performance regressions in a repository. You can check it out in my GitHub file, completely open source. So basically, you just need a autobench.yaml file that exports all the routes available for a benchmark and a GitHub action. So see the next example. I did a very bad PR, very bad change, and then the CI runs and told me, okay, there is a performance regression. You should not do that. I will not let you to merge it because there is a performance regression. And this is very good because the benchmark will run and the dedicated machine. Okay, don't use the GitHub actions, the normal container to do that. It custom runner, okay? But set up it properly, work, and also it will avoid a lot of performance regressions in production environment. And if I create a good PR, a good request, no performance regressions, okay, looks good to me. I approve and merge and happy for the rest of our life. Okay? So, okay. If you have any question about that, question about the entire presentation repository, you can talk to me on Twitter. And that's it from my side. Thank you so much for watching. And I hope to see you in other conference. That's it. See you later. Bye bye.